Okay. We can rewrite the 75 using common angles. So the 75, can you think of a combination of the common angles that will give you 75? 45 and 30, yes. So if I rewrite this as the cosine of 30 degrees plus 45, what happens, this becomes our A and this is our B in these sum formulas. Remember, cosine's formulas, the functions stay together, right? So it'll be cosine, cosine, sine, sine, and then the signs are swapped, right? They're opposite. So if it's a sum, then in the formula it's going to be a difference. So here's how we use it. So it'll be cosine of A, 30, cosine of B, 45 degrees, minus sine of A, sine of B. So sine of 30, sine of 45. And now we don't need a calculator because we can compute this stuff by hand. The cosine of 30 is going to be root 3 over 2. The cosine of 45, root 2 over 2. Minus the sine of 30, 1/2, and then the sine of 45, root 2 over 2. So our final answer, and the denominators are 4, right? So the final answer we're going to say is root 6, because root 3 times root 2 will be root 6, minus 1 times root 2, all over 4. And that would be the exact value of the cosine of 75. So if you punched in cosine 75 into your calculator, and you got the decimal for that, and then you went ahead and computed this decimal with your calculator, they would be the same. It's the same number. So this would be on a no calculator part of the test. You know, like we have no calculator part, this question would be there, because you don't need a calculator to find the value. What if the measure is in radians? What can we do? Convert it, but there's another way to do it. Remember, the goal of this is we rewrite here using 30, 60, or 45, right? Whatever combination works. And so the same thing would be true for this problem. Except since it's in radians, I want to look at it in radians instead. So I want to see, is there a way to write 13 pi over 12 in terms of pi over 6, pi over 4, pi over 3. To make it more obvious, what I would do is I want the denominator to be 12, right? So I would rewrite these in terms of the same denominator. So I would write pi over 6 as 2 pi over 12, pi over 4 as 3 pi over 12, and pi over 3 as 4 pi over 12. And then I would ask myself, well, is there a way to form combinations of these, any two combinations, multiples of them as well? I can use multiples of these that will add up to 13 pi over 12. Anyone have the combination? Nicholas, you look like you want to tell me.
2 pi over 3 is 1 pi over 4, and then 1 pi over 6.
How about, is there a way to just use two of them? You can always take those and put them together. Yeah, that would also work. But let's give it one more shot here. So say it one more time. Give me the numbers you said. How many again? It was. So you said, well, give me the numbers you gave me originally. 2 of these, 1 of these, 1 of these. Okay, so we have, that would give us 8 of these, right? And 5. That would be 13. Correct. So you can put these together, right? That would give you 5 pi over 12. Or that's not, actually, I don't want to think of it like that though. But it would work, but you put these together and then this one. But I think it was one of them, they would still be in terms of denominator 12. You know what I mean? So that would be still okay. But it would, maybe there's a way to get it to work, yeah. So 3 of these and 1 of these. Well, or no, 1 of these. So 3 of these, that would give us 9 of these, right? That would be 9. So 3 times that, 1 times that, so that would be 9 pi over 12 plus 4 pi over 12. That would give us 13 pi over 12, right? So what that means then is that what I would write over here is 3 pi over 4 plus pi over 3. I just use this part to figure out what will add up to this, but then I use this as my angles over here. Then, in my formula, this is my A and B. So this will be equal to, for tangent sum, you add the tangents on top, and in the bottom it'll be 1 minus the product of those tangents. So it'll be tangent of 3 pi over 4 plus the tangent of pi over 3 divided by 1 minus the product of those. Tangent 3 pi over 4, tangent pi over 3. And then we would work out each piece. What's the tangent of 3 pi over 4? Well, we are in quadrant 2, and the tangent of any pi over 4 is always going to be 1. So if we're in quadrant 2, it should be negative 1. So the tangent of 3 pi over 4 will be negative 1. The tangent of pi over 3, so that's 60 degrees, so that's going to be root 3. So plus root 3. And I've already found these numbers from the top. So for the bottom, it's going to be 1 minus a negative 1 times a root 3. So just cleaning it up one last time, it'll be 1 plus root 3 over 1 plus negative 1 plus root 3 over 1 plus root 3. You don't need to rationalize. If you want to rationalize, you can rationalize, but you don't need to. You can leave the answer. All right.